Okay, so this whole Delta Math homework. If you got done, cool. If you're still working on it, that's okay. Just get done whatever you can. So these are just like asking questions we've done already. Like, hey, what are some of the interior angles of a pentagon or whatever, right? Now, in case you guys forgot the formula, it's this. That's the formula. And penta means how many sides?
Five.
Five, and just plug in five, and you're good. You get 540. Or if I do another problem, this one using diagonals from a common vertex. Vertex is a corner on the shape. How many triangles can we form from a 15 gon? Well, I'm not gonna draw 15 sides. It's kind of crazy. So what you can do is you can look for patterns, right? Like let's do six. Six is pretty easy to draw, right? And if I try to draw diagonals from a corner, one, two, three, how many triangles did I create? Actually, four, right? Right. Or if I do or let's say if I do a pentagon, or we'll do an octagon actually. We'll do a larger one here. Okay, and let's draw those diagonals. So you got one, two, three, four, five. But you have one, two, three, four, five, six. So we see a pattern. It's 13. So don't try drawing 15 sides. That's crazy. Please don't do that. So if we look at the solution, yeah, they're going to draw it. They did actually draw it, but it's not necessary. So look for patterns. That's just good problem solving skills. Level two, what's level two about? Okay, it's a little more. Oh, hide the solution. So what's the sum of two interior angles of a regular pentagon? Well, now we know how to find the sum of all the angles. That's n minus 2 times 180, which is 5 minus 2 times 180, which is 3 times 180, which is 540. And if I want to find the sum of each interior angle, I do 540 divided by 5, because I have 5 angles, which will be 108. And then I want two of them, of course, add 108 to 108. You should get 216. So it's just a little more work. It's not, I won't say it's super challenging, it's just a little more work you have to do. Or what's another one here? Okay, how many sides does a polygon have if the sum of the interior angles is 4140? So I'm going to set 4140 equal to the formula, right? What's the formula again? N minus 2 times 180. And then this is where, actually, I could do this in my head. I think it's 23, but use a calculator if you need to. I think it should be 25, but calculator's okay. 25. I am sure of that, yeah. Extra angles of a polygon. What do all the extra angles add up to again? Yeah, so just add sum all equal. And you don't know this is regular, that's fine. But it's a five-sided figure. Fine, whatever. They give you all five angles of extra angles. Add them up, say they equal 360 and solve it. But then they want the small extra angle, so they don't want x, they want 2x, right? So report 2x as your answer. Or another question could be like this. Okay, same thing. Still 360. Okay, this is again kind of lame, actually. Yeah, these are all really, this should be really easy stuff. Not that hard. Identify polygons. Just count the number of sides or angles. That should be, and if it's regular, all of them should look the same. They don't. Actually, those count as regular because they use the same markings. Okay, because they based on looks. All right, whatever. Um, and what's the question? Yeah, this is convex. It doesn't cave in, and of course, it has count number of sides. One, two, three, four, five, six, and six sides. So that should be pretty easy too. And then just some old school stuff, like y64, x is 32. That's not that hard. Connor, go ahead. Yeah, correct. Yeah. Yep. What did they say in Delta Math?
Decide whether it's convex or non-convex.
Okay, same thing, concave. Yeah, I remember for a rhombus, opposite angles are the same. So z is 59. Now the thing is that how do I get y and x? Well, I know they have to have the 360, so I could take 360, subtract it from 118, because 59 plus 59 is 118. That should be what, 242? And you got split equally, you get 121. So y and z happen to be identical because they're opposite of each other. Or you can use alternate same side interior angles, apple 180, that works too. And it's more the same stuff. It's just more algebra, not that hard. Um, oh, that's the solution. Yeah, so 3x minus 6 108. Now here's the thing, if that's 108,
D minus 3 has to be 72, or Y minus 1 has to be 72. The same side as your angles, right? At that 180. So we're good.
Okay, so that was delta math. Hopefully you guys are okay there. Not too bad. All right. So, and I think next week we'll aim to probably do a quiz. Let me talk to Mr. Davidson when we're having our next quiz. But the reads. Oh, I do need to give you guys back your tests. I've not done that yet, so let me do that right now.
Not next week, partners normal.
I don't know yet. Let me talk to Steve. I think we're due to doing a quiz soon, but I don't know yet. Let me talk to him first.
Oh, I'm not gonna be. I will be here Monday, but we're hiring a new teacher. I'm not going anywhere. But we're hiring a new math teacher next year. I don't know, but someone's we're interviewing somebody. It's actually was a former student. His name is Gus. Also, Gus Gurley is his name. So yeah, he's a former student. Oh, he's probably like 24. He's like half my age. I'm 48. Yeah. Was that? I can make a pitch for it. Well, thank you. I appreciate that. So, anyhow, what was I gonna say? So just make sure you guys, are respectful and treat him, just,
He's teaching us.
oh yeah. So Ms. Wong and I will be observing, and so we have to see how he does, right? Forever, no, for one day. No, on Monday. No, it's the interview. He's interviewing for a job. That's what I said. He's interviewing. No, don't do that.
So scary for him. Yeah. Poor guy.
Well, back in the day, we used to have like 10 teachers observing, but only a couple teachers.
Wait, so should we like act like normal?
Yeah. Back normal, yeah.
You have that name now.
I have name tags for you guys, so. Yeah, just slow down this. Yeah.
Or if you're
I will say one more. I submitted my photo.
Okay, so next week we also have a retake.
That's for this test we just had, or the combination of the quizzes in January. Remember we had those two proof quizzes, but I don't think anyone got less than 80% on the quizzes, so I think we're okay there. But if you got less than 8% on this test, you are eligible for the retake. I'll send an email. I'm not sure if I got a chance to say, probably tomorrow I'll do that to give you a heads up, like, oh, you're eligible for the retake, blah, 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 whatever. So I'll talk about that stuff. But now I have, everyone's taking the test, and I know this is before ski week, so yeah, you keep it now. Yeah, just not everyone had taken it by that Friday or that Thursday before ski week. That was the issue. So, okay, let's pull up the notes and let's get going here.
So the retake will be on Tuesday.
On Thursday, during Y period. Okay, here we go. Yeah. Afterwards, about time. Okay, let's go to 8.1.5. So let's go to page, I think it's like page 21. No. He's going to teach, by the way, he's going to teach you guys this lesson here on 8.2.1. So, okay, let's start at 8.1.5. Here we go. Okay, so here's what you're going to do. We're going to do, so this table here will be a group of 3. Pure will be a group of 2. You guys will go do partners there, and Sabina and Connor will be partners. What I want you guys to do, I'm not going to teach this. I'm going to let you guys teach yourself. I'm going to walk around and help you guys out. Find the areas of each of these shapes with the given information. So, for example, you have a square, half the diagonal 6. What this tells, I'll doctor up the diagram just a little bit to help you guys out. So these are each 6, right? Yeah. And you have a triangle that looks like this. What do you think this angle is going to be right here? Correct, because a diagonal is a perpendicular bisector for a square. So you're using your knowledge of quadrilaterals, right? So A, B, C, D, and let's call the inside E. Oh, sorry, say it again. You're doing the math in your head. Got it. So you can look at it from that perspective. Try two different methods for solving this. For hexagon, remember we did that little teaching the other day. I know some of you guys weren't here on Tuesday. Um, so each side's 8, by the way. Each side's 8. And you're forming 6 triangles. If you form 6 triangles, what are the angles of these triangles? Like, what would this, let me use a different color. This will help out a little bit. What's this top angle here? What do you think that top angle is going to be? Who's grouped the hexagon?
Oh, 360 divided by 8.
Not 8, by 6.
Oh, yeah.
So go ahead, Kira. 60 degrees, thank you. Yeah, 60 degrees, thank you. And by the way, these are the same, right? Because they're both coming from the center. So what's going to be measured at these angles down here as well? 60, 60, right. What kind of triangle is this? 60, 60, 60. It's 8. It's equilateral. So you got equilateral triangles. So go and try this. You might need to do some trig. You might use some ratios of like, I'll show you some of my solutions after a few minutes. There will be. I'm not going to give it to you right now. No, you are ready. I want you to discover it. Yeah.
Those are the first methods for both.
I'm just giving you some hints. It's up to you. You guys do whatever you want. But I would strongly urge you to breaking it down to triangles. By the way, for hexagon, what if I did this here? What's happening here? What am I doing now? So what 2 shapes do you make? You can do trapezoid if you want. So maybe you and your partner could try 2 different ways and share. Do what you can. If you're stuck, I'll help you out. Okay. So for square guys, here's what's happening. Look what I traced in red. I traced one of the triangles off to the left and just put it up top. So you have the half diagonals are 6 and 6, and they form a right angle, right? If I do Pythagorean theorem, or let's call this like say x. If I do Pythagorean theorem, I should have 6 squared plus 6 squared equals x squared. So 72 equals x squared. Yes, you got square root it, which is root 72.
How did you get 72? That's not 72.
Oh no, because root 70.
Root 70. No, root 72. Hold on, we're not done yet. That's what x is. So each side is root 72.
So it's root 72 times root 72, which is just.
But we're not doing perimeter, we're doing area, right?
root 72
You want to multiply
squared.
the sides together. When you multiply radical by itself, the radicals just go in and get 72. Now, another way you could have done this too, you could have done the 45, 45, 90 ratios. It's okay if you don't remember, but it's a 6 root 2. 6 root 2 is the same thing as root 72. Those are identical. If you multiply 6 root 2 to 6 root 2, you will get 72 still. This other method that's shown here, what they did, they actually chopped up this square into 2 triangles like this. So if they chop it up this way, how long is that purple line? 12, good. And that's another right angle, right? So if I have another right triangle like this, but now I know the hypotenuse, not the legs. If you think about it, that's like saying x root 2. So you can solve for x. Once you get x, you have the length of the sides, and you still get the same thing. You still get 72 if you work it out. So that's yet another way to do it. Or you don't have to draw this right angle here. You could draw the altitude. If you draw the altitude, that's 6 and 6. And again, I could still and then I could just take half the base times height, half of 12 times 6. I think that's easier. I agree. That's 36. So each of those triangles is 36 and 36. You still get 72. So there are multiple ways you could have done this. But I think we're in agreement, 72. And we're pretty comfortable finding it. Okay. Hexagon. Did anyone get an answer yet? Okay. I won't show the answer. Let's talk it out. Okay. So I think we're in agreement that if you draw a bunch of triangles, how many triangles do you create? From the center, you can create 6, right? Good. Create 6. Now, that's 8. And by the way, these are also 8. That's because this right here is 60 degrees up top. And the two sides that form the vertex are identical because that's the radius of the hexagon. So you have an isosceles triangle, but even more, it's equilateral. So that's lovely. We have something very simple to work with. Then you can actually chop it up in half to make this. If I do that, that's 8. What's that going to be? 4, because you're cutting that in half. And if you use your 3690 ratios, 4 root 3. So now that's 4 root 3. So if I do 1/2 times the base times the height, I get 16 root 3. Nope, because the leg can't be more than hypotenuse. That'd be impossible.
That little part is 4.
Correct, right. It's always double, right? Because the ratio goes like this. X, 2x, x root 3, not 2x root 3. That'd be physically impossible, right? Correct. And you have 6 of these, so you get 96 root 3. So if I ask for an exact answer, you just leave it alone. You could multiply 96 by root 3 at 166 point something. So yeah, that works too.
Wait, is it 90?
96 root 3. Yep. So that's one way. That's probably the more popular way, I'd say. That's why I would suggest. You could also have done this. This might have been easier, I think. The triangles is going to be the best way because it's going to lead us to a formula that we'll eventually derive. But if I do this here, how long? This is going to be a little tricky here. So notice I'm creating a trapezoid, right? That's 8. What's the top side going to be of this trapezoid if it comes from here? 16, because it's 2 of the diagonals, or 2 of those sides. And we had to still find the height, which, you could use like 30, 60, 90 ratios or whatever you have to do, or trig, is 4 root 3. So it's 1/2 out of the 2 bases times the height. You should get 48 root 3. But remember, you got 2 of these, right? Add them up, you get 96 root 3. Cool? All right. Okay, so I think we had a discussion. I don't need you guys to teach this. So let's just move on. Or actually, let's look at 840 really quickly. Which geometric tools does this method use? Well, definitely used triangles. That's not really a tool, but we use like our triangle knowledge, I'd say. You could have got more creative if you wanted to, but yeah. Yeah, maybe trig. Pythagorean theorem, I think that's a great observation there. Yeah, Pythagorean theorem, right? 30, 60, 90. Or 45, 45, 90. And would this method help find the area? Yes. But use triangles. Triangles are going to be your best bet. Because you're always going to make triangles out of these. Always. 100%. And we talked about that on Tuesday when you guys taught those you taught like all the information about those polygons. So okay. Let's try some more. Yeah. Yeah, good. Okay, yeah. No, one. No, what happened? I'll tell you what happened. So when you interview for this place, actually, I have a funny story. So when I interviewed,
I got hired this summer. And we didn't,
This summer?
summer of 05,
Oh.
21 years ago.
And some teacher like left at the end of the year and just I don't know, was unhappy about something. I don't know why, but and so they're scrambling to find a teacher and they didn't have any classes this summer. So they had to get the kids from the pool and they were just fishing doing like water polo practice. And they're all in their t-shirts and flip-flops and swim shorts. And they had no notebooks. I was teaching, I was like in a full suit, it was hot that day. And yeah. But when you interview, you also have to interview with the director, so Mitch Dioli, Dr. Whitcomb, the department chair, other people. So it's a whole day of interviews, and then you teach a class. So, we've actually hired people who actually didn't do well, but we just really thought they had a strong potential. And we hired people who are great at teaching a class, and then we discover after a year, like, oh crap, they really are not good at this job. So you take it with a grain of salt. Yeah. Yeah, I'm just gonna give him the lesson plan right when he shows up here. Go teach it. No, we gave him a heads up on what he has to teach. Yeah, no, we give him I tell him the lesson, and actually we gave him the roster too, so he actually will know your names. If he memorizes, yeah. It is actually more I think about it. Something I didn't make that decision, so yes, I'm sorry, but I don't have an answer. Did I answer your question? Sorry. Okay. He should. I think so. Yeah, I think so.
I'm telling what a trader comes in, like, oh, right? Like, you want
Well, we don't ask those questions. I mean, that's more an HR human resource. I don't know.
like a paper of all our.
No, I think he graduated in 2022, so you'd have to be 26. Or no. I think he graduated before pandemic. I don't know.
Wait, should we be hard on him?
No, don't be hard. No, be polite. Be nice. Be respectful. Yes, 100% ask. Hold on. See if I can pull up the resume. No, because I just sent. Well, it shouldn't matter, guys. I mean, it's like Gus Gurley. Gurley. Yeah, exactly. There you go.
Wait, I don't feel good about it. Gus Desperately?
Gus Gurley.
Oh, Gus Gurley.
I don't know. You guys ask him. Actually, hold on.
Wait, is his real name Travis?
Oh, yeah.
Start talking.
He actually graduated right after the pandemic. So he graduated 2021. Yeah, he's actually probably 23 or 24. I guess so.
Do you want us?
He went to Carnegie Mellon, great school.
Do you want us to talk more so that like you see if you know that?
No, he's not gonna yell. No. No, don't do that. No, please don't do it. Please. Just be respectful. Just be respectful. Okay. Anyway, guys, it's a very common thing. Let's just move on. See? Yeah, looks like it. Yeah.
Remember Mr. B?
Okay, guys, we need to get going. Okay, this is not relevant stuff. All right. Well, kind of relevant. Okay, kind of, but all right, let's keep moving. That's okay. No,
On Monday.
on Monday, yes, you'll have a. And we're just so you know, we're interviewing a few other teachers too. We're not just like no, because we have to really make a decision pretty soon. So so he's doing another class. Like actually, we're interviewing someone today. So today's. Yeah, I don't know. Not my class. You can give me feedback. Give me feedback. Actually, we do value your feedback. So did you guys learn something? That's what I care about. And do you feel comfortable? You know, because mind you, he could be your teacher in a couple of years, right? So that could happen. All right, guys, let's move on. 849. So find the area of two regular polygons below. If your method does not work, switch to a different method. Assume C is the center of each polygon. So let's count the number of sides. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we got a nonagon. So nonagon. Okay, so I'm gonna draw this. Now this technique, I would say is a universal technique. Well, that's really good. Good kick. Okay. So anyhow, I don't need the letter C there, it's fine. All right. So what I want is we have 9 triangles, right? We have 9 triangles. Let's find one of them and multiply by 9. So you have an isosceles triangle. Does that make sense? Why it's isosceles? 11, 11, right? Okay. This is the whole key to doing the problem correctly. You need to figure out this angle. We need that angle. Yes, that angle, I'll label as ABC. So ABC. You know what? Why not? Doesn't matter. Sure, why not? Why not? Okay. So angle C is me 360 divided by 9, which is, of course, 40 degrees. Okay. So that's 40 degrees now. Now what I'm going to do is I'm going to chop up the triangle in half. This is still 11. That's a right angle. So I'm drawing an altitude, right? If I'm doing that, what's this top angle now? Good. And I'm going to create 2 letters for X and Y. X for the horizontal leg, Y for the vertical leg, right? So I have 2 legs. It's a right triangle. How do I solve for X, Y? This is actually the second key to the problem. You got to do SOHCAHTOA. So when you ask, like, do I need to know stuff from last semester? Absolutely you do. You need to know this. I mean, do you need to know like the trivial stuff like geometric mean? No. But do you know trig? That's a major thing? Yes. So X over 11, and I'll do cosine 20 equals Y over 11. And we're going to solve for each of these separately. So I'm going to use a calculator to figure this out. Once I've figured it out, then we're home free.
But it's really a 3-step process. And I'll summarize it when I finish. But then we have you guys try for the next one on your own.
Okay. So, and by the way, you must be in degree mode. Very, very important. Otherwise, your answers will be way off. So 11 sine 20, you guys should know multiply by 11. So that's 3.762. And for Y, if I do 11 cos 20, 3.6762. Check your mode. Your mode might be off. Oh, that might have been, you did cosine?
Yeah, that's the other one. Yes. Yeah, you're good.
Oh, okay.
Yeah, you're good. Yeah, that's for the vertical.
Yeah, for the vertical leg. Okay, so now I got my dimensions, right? Now let's look at this triangle one more time. Let me get rid of these other things here because they're getting a little distracting, right? Okay, so Nick, you're good?
Would be round.
You know, yeah, on the safe side, around the 3 decimal places. Yeah, just be safe.
So when I did sine 20 times 11, I got 10.0.
No. It's 11 times sine 20. You got reversed. Your angle's 20, right? You did the other way around. Did you put parentheses around 20? Yeah, what do you get?
Are you in Desmos?
3.76.
Yeah, that's radians.
But here it says degrees, so that's what I was
No,
confused.
yeah, versus. Yeah, it's confusing.
Okay.
Yeah, it's really confusing.
Wait,
It's like
3.7.
Right. So, by the way, X is half of the base. So you got to double it. So it's actually 7.524.
Wait,
And the height is still 10.337. Yeah.
Wait.
So my area is going to be 1/2 times the base times the height. And how many triangles do I have again?
not.
And you got to multiply the whole thing by 9. So I got to do 9 times 1/2 times the base times the height. And I should get, oh, it comes out really nice. It's basically almost 350. Yeah, I do, actually. As I was saying, this is heavy with computations. Okay. Very heavy with computations. You gotta be really, really careful. You guys could totally handle. So in lieu of proofs, we're doing this.
Wait, I got around like 427.
Okay, let me come check your because something's off with your calculator. Do you have a graphic calculator you can use? Might better. You want to use this or use this one? Here.
Thanks.
Yeah. Okay. So William, yes. Yeah, good. Yeah, of course. So here's the deal. What you want to do is find the central angle. Okay. Two, find the base and height. And three, find the area. That's your three-step process. Find the central angle, find the base and height, find the area. Okay, I think you guys can handle this. I'm going to let you guys do part B. Let's see if anyone can get part B. All right, and then by the way, let's count the number of sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a decagon. Okay. We got ourselves a decagon. Okie dokie. Let's do it. See what you guys got. I'll show you the solution in a moment. For the first for part A still?
Wait, why?
Hold on.
Cause this times 2 is that.
Yeah, okay, good. So then that's 7
Oh,
plus
I
6
got it.
2.
I got it.
Done.
Central. 7, 5, 2.
So 7 points.
Times.
10
10.
points.
Oh, 7.
Yeah.
Yeah. What's that?
And 5 by 2 times 9. You have 9.
Oh, that's what I did
Right.
wrong.
Yeah. Like 9.
36. Oh, okay.
Close to that.
Oh my god, now I'm sure.
No, Marshall, it's like given that they're regular.
Yeah. Oh, by the way, yeah, they do say so at the top. We're assuming regular polygons, 100%. Sure, yeah.
Wait, for the second shape, can we assume that like from each angle to the center is also 5?
From here to here.
From like at each angle to the center to that also. Can we?
Yeah, they're all gonna be the same everywhere, right? You're gonna create 10 congruent triangles.
Okay.
But the 5, by the way, is not the slanted side, it's the hypotenuse. Sorry, it's a height. It's the altitude. The 5 is altitude.
Okay.
Because it's regular, we can assume that all the values that are inside are cutting at angles.
Correct, right.
Because you only need to find those 8.
Correct, right. Actually, Mr. Davidson students actually did a little bit more color. Guys, that's my fault. I should encourage you guys.
It's all right. They're good though. I'm glad we got them up. Yeah. Yeah.
Pyramid.
Okay, okay, yeah.
I got ultimate wrong this one.
You got what? Let me find out. I don't know. You nailed it. Spot on. Good work. Good work, Kira.
Let me do mine first.
Yeah. Let's do it. Okay. Good. Boy.
Base. The area of the triangle.
Correct. Right. And then multiply by 10 afterwards. So I'll kind of start working it out a little bit.
All the ones back there better.
That's Mr. Davidson's back there.
Wow. Artistic people.
No, he just encouraged him to do because it's my first year teaching geo, so I didn't know what I was doing with you guys.
It's not Mickey.
I like the kite one the best. That's the only like mini.
Yeah.
I got 166. There you are.
Hold on. Let's talk about the angles. So each angle is 36 degrees, right? But then when you cut it in half, you get 18 degrees. And I'll call this X, right? So tangent, you're gonna do tangent, right? Do you guys are you using, excuse me, are you guys using tangent? It happens, hey. You know, it's all good.
No, we're gonna area.
Can I borrow a calculator? So you should have 5, tan 18. The base should be 1.625, but you gotta double it up. I mean, double it up should be 3.249.
I just rounded 2.5. Is that fine?
So it's fine, yeah. So you should get 8.123 times 10. Yeah, you should get 1.23. So once you get very good with this, you can kind of start moving faster. So notice I found the angle, did trig, and found the area. So remember, this is a decagon. So it should be 81.23. Let me show you the solution key as well, a cleaner one. So here we go. That's the solution right there. 36 degrees for the central angle, but half 18, tan 18 is x over 5, solve for x, double it up to get the base. And multiply by 10 to get the total area. So
I got 81.2.
yeah, it's close enough. It's fine. Yeah.
Off a little bit.
It's not too big a deal. No, that's fine. I'll be pretty good in that regard. Okay. Now, so in summary, what are the things you could do? I know there's a lot being written here. Just feel free to write whatever of these you want, but I say divide into congruent triangles. Figure out how many triangles there are. Find the central angle. Draw the height. Use trig. Calculate the area. Multiply by the number of triangles. Done. I actually wrote in 3 steps. He wrote it down in 8 steps, but I think I consolidated the steps. So again, central angle, base height, find area. That's all you're doing. So all this right here is for area. All this right here is for base and height. And this right here is to find the central angle. No. Honestly, central angle, base height, area. I think these are the finer details. You guys, this is in Schoology, so it's okay. Yeah.
Central angle, base height.
And area. Okay, let's do a couple more, then we're done. Sure, yeah. Yeah, we still got some time left to do some more. We can wrap this up. All right. So I'll do this with you guys so we move faster. Bethany is a fertilizer flower bed, which is the shape of a regular pentagon. Bag frozen states it can froze up 150 square feet. Actually, I had to do something like this in our backyard, something like that. But we don't have a Pentagon. We have like vegetable boxes are shaped like rectangles. But I actually had to figure out how much soil to buy, right? I actually had to do this math, right? So it's kind of a neat problem. A bag of fertilizer states it can fertilize up to 150 square feet, but that's not sure how many bags to buy. She knows that each side of the Pentagon is 15 feet long. Find the area of the flower bed and tell how many bags of fertilizer to buy. Of course, there's a depth you have to consider, but we're not going to do 3 dimensions today. So, so here's what I'm going to do. I'm going to make my triangle, right? Make my triangle. 15. Hey, Kara, what's up?
Like, very off.
Depends how topic we've only got 10 more minutes left. Okay, go ahead. Yeah, go ahead. Yeah, go ahead. But we'll see if I have time to answer it. Yeah.
Before, did they ever do like word problems like this, or was it just like plain?
Good question. I don't know.
Because I feel like they just started like.
CPM has a lot of word problems, that's for sure. They do. That's a really good question. I don't know.
They just, like, did like 115 about it. You know?
Maybe. Anyhow, each central angle is 72 degrees. So half is 36. And when I do this Pythagorean theorem, or sorry, this trig business, that's 7.5 and 36 degrees. Actually, let me change this up a little bit. That's 72 and a half, 72 is 36. The height. How do I solve for the height? Tangent. Right. And notice that like instead of the radius or the height, now I'm giving the base, right? So I'm giving all these different things here. Solve for h. Okay. $10.323. And then area, we'll do 5 times bracket 1/2 times 15 times 10.323. And you should get
Then you don't have to do it that. 1/2.
Wait, what?
Because I.
no, because I'm finding the area of each triangle. Of course, you have to do 1/2.
There's like, find the area of one of the sides.
So why?
There's.
What?
Like,
I don't know. I feel like brackets. No, but Peter, no. One of the triangles is base of 15, the height of 10.3. So to find the area of that triangle, I have to do 1/2 times base times height.
No, I was saying like.
You
find
could-
this.
But sure, you could do that. That's fine too. Sure. Now, however, how many? This is not the question. Not the area. The question is how many bags I need to buy. How many bags am I going to buy, guys? So if I divide by 150, 6? No, 3. Because it comes out to 2.58. But you're not going to buy 2.5 bags. So you got to buy 3 full bags of some extra left over for another project. Sure. We found area, but we need to find the number of bags to buy. Oh, 387. What do you get, Colette? 774, because you forgot to divide by 2. That's why. You're off by a factor of 2. Yeah. 387. Yeah, you're exactly off by a factor of 2. Okay, let's try another one here.
money treatment.
It is actually. Yeah, I didn't even realize because there was like nothing on there. Well, it doesn't need much water because I water right before break, but I just. But the sun, that's it. It's the daylight, yeah. So I had in the garage. I wasn't getting much sunlight in there, so. But you don't want outdoors because the elements could like the frost could be bad for it. So That's for the auction. Because we do a donation. It's a wine bottle. So the auction does involve a lot of alcohol sometimes. But anyway, that's how we make our money. And I'm being recorded saying that. Anyway, let's keep going. All right. It's true though. It's true. Every school does their auction around March, April, right before tax season.
I don't know, what tuition?
What was that?
What happens with the tuition?
What do you mean tuition?
Like the tuition students pay, is that not? Like all the money,
Towards the auction?
no, for the school. Cause you said the auction is like how they make.
Oh no. It's just we like to use alcohol to get more money. That's what I'm saying. Yeah. The auction actually just helps a little. It's really we make most money from the annual fund. But we do make good money from the auction too. Okay. You guys quiet. All right, for 852. Here we go. So what we're trying to find here, a major part of the cost of a window is the amount of glass used to make it. The more glass used, the more expensive, obviously. Your principals turn to your class to determine how much glass the window will need, explain how to find the answer. So what you want to do again is find central angle. Because we're trying to make a stained glass window. Use trig to get base and height. And of course, find the area, right? So that's what we're gonna do. And again, you're told that the radius of the octagon is 2 feet. And we need to figure out, and the edge of the glass will have a polished brass trim. Each foot of trim will cost $48.99. How much will the trim cost? Okay. Okay. So actually, we don't need area in this case. It's gonna be much easier. If it's, yeah, but we're not gonna, I just explained it. We're not gonna find it. So that's 2 and 2. Okay, central angle, guys. It's octagon. 45. We know this, right? Good. So now I make a triangle like this. That's 2. What's half of 45? 22.5 degrees, right? And I'll call this x. How did I solve for x? Sine. Thank you. So 5.227. But the trim is actually double that. It's 10.452, 10.453. And it's saying each foot of trim so if you think about it, my perimeter is what I need. My perimeter is going to be 8 times that length. And then multiplied by the cost per foot. Oh, crap. You're right. Darn it. Thank you, Maggie. I know it's going to be too expensive. I'm going to do this fast. I could just. Yeah, that was way too much money. Yeah. 0.76. So it should be 0.765. My apologies. Multiplied by 2, which is 1.53. Times 8 times the cost. Should come out to almost $600.
Wow.
What? No?
Yeah, $600. Full trim. All right. Cool. Okay, we're all set. Homework is in the packet. Should be in school as well. Homework number 17. You guys know what to do, and we're all set. See you guys on Monday.